Caddie's smart imagery framing and truthing SIFT platform is the only fully automated multimodality annotation tool in the market capable of identifying 69 and 47 med-DRA compliant abnormalities on chest X-ray and chest CT, respectively. SIFT streamlines curation workflow for reviewing and validating the annotated data, as well as resolving any errors or discrepancies to assure accurate and consistent annotation. SIFT platform reduces inter- and intra-observer variation, enhances and accelerates the training of trustworthy AI. SIFT annotation results include the locations and fine-grained boundary of desired lesion, comorbidities, if any, and semantic text. In summary, AI integration enhances annotation accuracy in diagnostic imaging by automating complex pattern recognition, speeding up workflows, ensuring consistency, and incorporating clinical context, all of which contribute to more precise and reliable medical image annotations that support better clinical decision-making. AI-assisted DRG, diagnosis-related group, coding with diagnostic imaging support, uses artificial intelligence to analyze images and assign accurate DRG codes, streamlining the coding process and supporting correct hospital reimbursement. Let us start with a landing page where user inputs its credential for authentication. Upon successful login, users are presented with a dashboard displaying a list of existing projects in a structured table format. Each project is uniquely named for clear identification and traceability. A project may contain one or multiple medical images. For X-ray studies, the system supports processing between 80 to 100 images per project, depending on file size and format. For CT scans, the limit ranges from 10 to 20 images due to hardware constraints. In this demo, we'll walk through the process of creating a new project and exploring the details of an existing one. To create a new project, users begin by clicking the Create Project button and entering a unique project name along with a brief description. Next, they select the anatomical region the project will focus on. In the current release, SIFT supports only chest imaging, with plans to expand to additional body parts in future updates. Users then choose the imaging modality, either X-ray or CT. Once these selections are made, clicking Create Project advances to the next configuration screen. Here, users specify the abnormalities they wish to evaluate. Multiple selections are supported, and abnormalities can be chosen from a drop-down menu for convenience. Finally, users upload the relevant images. They may choose to upload a single image or an entire folder. For folder uploads, the system supports up to 80 to 100 X-ray images or approximately 10 CT images, depending on file size and format. For demonstration purposes, we'll upload a folder containing 3 images. After selecting the folder and clicking Start Uploading, users can monitor the upload progress in real time. Once complete, the project dashboard displays key metrics, including total number of images, number predicted, reviewed, curated, skipped. To view image-level details, users can click the Data List tab within the project. To review a project, select it from the dashboard and click anywhere within its row to open the project details. Inside the project view, you'll find a list of images along with SIFT-generated predictions for each one. To examine an image, navigate to the Action column and select Annotation and Curation from the drop-down menu. This opens the image viewer, displaying the SIFT-generated annotation overlay. On the right-hand panel, detailed information about the annotation is presented, including prediction confidence and abnormality type. On the left-hand panel, the Tools section provides interactive options for users to evaluate the image further, adding, modifying, or deleting annotations as needed. Beneath the Tools section is the Action Toolkit, where expert reviewers validate annotations before proceeding. Check or Check in Next confirms the annotation and moves to the next image. Double Check in Next is used when a second expert review is required for the same image. If an image is not suitable for review, it can be skipped. Let us now focus on specific cases, focusing on SIFT annotation. In this X-ray image, SIFT identified 5 abnormalities. Secondary TB in the left lung. SIFT probably can widen its area. Nodule. A nodule appears inside the region of COVID-19 ground glass in the lower lung. This nodule is not identified in the radiological report, probably due to the fact that TB is the primary concern of the physicians. Mass. Identified by SIFT and appears on the upper left lung close to clavicle. Next case to review is the NLSDCT case with nodule as the main focus. Nodule 1, about 3 centimeters. Upper left lung that covers 6 slices, hashtag 29-hashtag 34. This one has nodular shapes and density is relative low. This patch-shaped manifestation may be ground grass opacity due to infection. Need a further workup. Nodule 2, upper left lung that covers 3 slices, starting at number 46. This is similar to nodule number 1. This one has nodular shapes and density is relative low. This patch-shaped manifestation may be ground grass opacity due to infection. Nodule 3, a small nodule, less than 1 centimeter and occupying 2 slices starting at number 44, on the right lower lobe on the back of patient. The density is relatively high. This may be benign nodule and need to be followed after several months. Nodule 4, a 3 centimeter solid nodule occupying 4 slices starting at number 54, on the right peripheral region on the side of patient. This one overlaps with vessel and can see spiculated shape of the nodule. This will need to have workup to determine whether infection, scar, granulomas, or adenocarcinoma. Nodule 5, an elongated object in left lung and only occupies 1 slice, number 92. It is most likely the vessel, which is false positive generated by SIFT. Nodule 6, a 3 centimeter suspicious object on left lung, middle section, slice number 97. Epoxy's round shape on cross-section view, but only extend into 2 slices. This probably is a scar due to infection. In summary, by systematically analyzing all pertinent clinical and imaging data, SIFT/bonus reduces the risk of miscodes, underpayment, and most importantly provides standardized annotated datasets for AI companies and research institutes to build accurate diagnostic products. Join us in transforming radiology.